So before proceeding, let's reset the simulation. Notice there's a reset simulation button that will move the ball back into place. Then on the left side of the MassFX toolbar, let's click on the Display MassFX Properties, Tool Properties. Notice the ground plane is checked. The option for the ground plane is checked. That's why the ball didn't roll all the way down the ramp. Once it detected what was the ground plane, in this case the 0 axis for our project, it stopped there and just rolled straight. So let's uncheck that. Let's close that and let's run the simulation again and see how it works differently. Now you can see the ball just goes all the way down the ramp and then kind of falls off like it should. Again, we'll reset the simulation before we try the next step. Alright, let's check out a few of the variables that can be tweaked using the MassFX tools. Let's first select the ball if it's not selected already, and then be sure your Modify tab has been selected so we can see the Modify properties. And right now, if you check out the Rigid Body properties, if it's not rolled out, click to roll that menu out. And you notice gravity is one of the variables that is by default checked. Let's uncheck it. Uncheck the Use Gravity option. Now let's run the simulation to see how the ball reacts without gravity. And you can see it doesn't move. Okay, so we need gravity or some force. Later on we'll see how to maybe use our own forces, but right now we're going to use the default force of gravity. Again, with gravity on, we can see the ball falls down and bounces around and off the ramp. Let's play with the physical material properties. Right now we see the bounciness is set to 0.5. I don't believe you can set it higher than 1. If I type in, say, 3, it's going to reset it to 1. But let's see what a bounciness of 1 does when we run the simulation. Well, you can see the ball is much more bouncy now. Let's reset it and try it at 0.1. Oh, right, much less bouncy. Let's go back and set it to 0.5 as it was by default. Okay, so we'll stick with that bounciness for the purpose of this demonstration.